probabilities and the outcomes and possible events of the experiments that we're running, all of this can be quite overwhelming when we try to keep track of everything. And so a lot of times we turn to a form of visualization known as a Venn diagram. And this allows us to kind of sketch out the possible events within an experiment space. And so we're going to do that here, and it's going to help us dig into some further concepts. So a Venn diagram is comprised of an outer box, and then what you'll typically see are circles within that box. So the box itself is all of the possible outcomes, or contains all of the possible outcomes of an experiment. So the box necessarily then sums to 100%, right, or 1.0, because all possible outcomes must fit in there, and they must sum to 100%. Within that, we can then draw circles which indicate events. Okay, and so in the generic sense, we often say, this is event A, and so the probability of A would be, in some sense, the size of that circle. Now, obviously, when we're drawing, we estimate a little bit. It's not necessarily exactly right, but typically we would draw, an event that has a larger probability in a larger circle than one that has a smaller. So event A is that probability within there. So notationally, or when we write it out mathematically, we again refer to this as the probability of A, the probability of event A happening. And maybe we say that's 0.15. Okay. There's a 15% chance within this experiment that event A happens. One helpful concept in probability is considering the chance that something doesn't happen. So in this case, what's the chance that event A doesn't happen? Well, what this is called is the complement. And it's easy to see on the Venn diagram because it is, maybe I should have written this in a different color, but the complement is everything outside of event A, right? So the box contains all possible outcomes. Some of those outcomes result in event A having occurred. Some of the outcomes do not. And so if there's a 15% chance that event A happens, the complement of that, or mathematically what we call it, is the probability of, this is referred to as not A, or I just like to say squiggle A, the probability that A does not happen. Okay, and in this simple case, we probably know that that's 0.85. Okay, because again, they need to sum to 1. So where mathematically, or we can keep this in a more general context, because sometimes we'll come across more complicated scenarios. But the key here is that the probability, you just switch that up. An important rule here is the probability of A is 1 minus the probability of not A. Okay, and so 0.15 is equal to 1 minus 0.85, or in reality, we have the probability of A, so we could solve for the probability of not A. Again, this seems very kind of obvious at this point, but this is a useful trick to remember. It's kind of a trick of probability questions, is to not only think about the probability of A, but sometimes it's easier to calculate the probability of not A. And this will be illuminated as we work through some practice questions and in your assignments. But yeah, keep this in mind that we can solve questions. So if it's very hard to find out what probability A is, sometimes it's easier to figure out what the chance of it not happening is. And again, that is sometimes easier to remember when we sketch things out in a Venn diagram. So we can put more than one event in a Venn diagram. So let's just put another box out here. Okay, and so this might contain, maybe this is event C and event D. Oftentimes we just write the letter, but so event C and event D depicted on the same Venn diagram. And we can continue, right? So this might be E. There's still a complement, or we could consider the complements of all these different ones. So we could have a not C, we could have a not D, we could have not C, D, and E. And so the complement is more flexible than just one event. But now you can start to see how we can build this Venn diagram to make sure we're keeping track of the possible events. And now what you're more familiar with Venn diagrams are not these, or the kind of the popular way to depict or use Venn diagrams is to show an overlapping of a situation. Okay, so we can draw Venn diagrams. So first, these three events right here are mutually exclusive. Right? Remember back to the first time we learned about mutually exclusive, meaning that if one event happens, the others have not occurred. Okay, but this is not always the case. Consider if two events that we're interested in is rolling a 2 on a die, or another event we're interested in is rolling an even number. Okay, and so in this case, they would be overlapped. That one would be inside, but the events do not have to be mutually exclusive for us to be interested in them. Or a more general sense, or a more classic Venn diagram where they're just overlapped. Perhaps something like in a poker game, you either need a heart to make your flush, or you need a king to make your full house. And so you're okay with any of the hearts or any of the kings, including the king of hearts. And so that's depicted as an overlap of the two events. And so that brings up the fact that there are so when we think about adding probabilities together, that's going to be important to keep in mind. And so we'll talk about that in a future video of how do we combine events and think about them jointly. So that's a quick introduction to Venn diagrams, and we'll use them through on all of our probability studies.